Hello. So today is a new format. I'm just trying this out. I think the YouTube format actually worked better than the Blackboard format, and I think more people might watch it more frequently, and I can get the view count. So I think it's all really good points that I need to probably switch over to YouTube, and it makes things actually video recorded. So I'm going to do these YouTube videos, and I'm going to just put out a series of videos, including some of the stuff to recap previously in the class. And we're gonna launch this new method with the analysis of variance lecture, which is ANOVA, and I'll be posting this in the course content section, and I will make a new section called YouTube videos. So look forward to that, and I'll do that today after I finish recording this actually. So for analysis of variance, what you're doing here is it's just like a t-test kind of. Well, it's sort of like a t-test. It's a statistical test designed to examine the means across more than two subjects. It is based upon variability, so this is like variance, like standard deviations. And the ratios of variance are used to determine if there are differences in the groups. So variability in statistics is how spread out your data points are exactly. And this is commonly referred to as variability or dispersion. There's no limits to the number of groups you can t-test. I mean, you can use ANOVA for, unlike the t-test, which t-test limits you to 2. And under ANOVA, the null hypothesis is that means for all the groups are equal. So, you're just looking for a difference between the groups instead of like, equality. So if things are equality or even close to equal, then you need to accept null. But if things are not equal, then you reject null. So generally the hypothesis is that at least one of the groups are different than the rest. So when scores are divided into 3 groups, the variation can be divided into 2 parts. The variation scores within the groups, think standard deviation, and the variation scores between the groups. So you got within and between, and how the scores vary from one group to the next. ANOVA can then compare these 2 types of variances. So that means the heart of ANOVA involves whether the difference between groups variance is significantly larger than the within groups variance. The statistical procedure in ANOVA is called your F-test, and that's what the big deal is. You were looking for that F-test. The F-test shows that ratio of the 2 estimates of variability within groups and between groups, and if the null hypothesis is true, then the variation between groups should be very similar. If the null hypothesis is false, then you should see differences. So always remember that the ANOVA always tests the null as no difference in variation between groups. Again, going back to that null hypothesis, you're looking for to reject null, you're looking for a difference in the group. But if you accept null, it means the groups are the same. F-test value is statistically significant, then you reject null. If the null hypothesis is true, you expect to have a F to a value close to 1 most of the time. A larger F ratio, which is 5.14 plus, means that your variation among group means is more than you'd expect by chance. So basically what I'm saying here is, if you have a small F value that's close to 1, then null hypothesis is true. But if you get a bigger F value, and it can be more than 5, it can be less than 5, but you're around that number, you're going to reject null. So ANOVA requires the following. The data must be from a random sample from a population. Okay, cool. The single dependent variable must be measured at an interval ratio level. So we're looking at interval ratios only for this. The independent variable needs only to be nominal, ordinal. So you can convert interval ratios to ordinal or nominal, but you can also have interval ratio variables for independent variable here too. Interval ratio variables are nice in that fact that you can use them for about anything. Honestly, very few things can't be used. You can convert any interval variable value to nominal, ordinal, and this is like an example, right? Coding is kind of what we were going over in class, previously. So you can organize these, 0, 0. A coding of 1 is 1 through 25. A coding of 2 is 26 through 50. A coding of 3 is 51 through 75. A coding of 4 is 76 through 100. This method puts your interval ratios into 5 ordinal categories. You can name these categories: 0, no crime; 1, little crime; 2, moderate crime; 3, major crime; and 4, severe crime. So here is an example, a YouTube video within a YouTube video.
This is Stephanie from statisticshowto.com, and in this video I'll be showing you how to perform a one-way ANOVA in Microsoft Excel. In this experiment, cancer patients were given drugs to relieve their pain. We have drug A, drug B, and a control, which is a placebo. The patients were asked to score their pain levels on a level of 0 through 10. And we want to know, do drugs A and B actually work, or how do they compare to the control? On the Data tab, click on Data Analysis on the right-hand side. If you don't see Data Analysis, you have to install the Data Analysis Toolpack. You can follow the link on the video showing right now to take you to the video on how to load the Analysis Toolpack. We'll click Data Analysis, choose ANOVA Single Factor. The reason we're choosing the ANOVA Single Factor is we only have one variable we're looking at, and that is the pain level that the patients are reporting. Click OK. Our input range, I'm going to select that with a cursor. And check the box that says labels in first row to let Excel know that I do have labels. My data is grouped by columns. If it were grouped by rows, you would choose the second option. Output range, I'm going to select an area just underneath my data. And my alpha level of...
Now you can, click the new worksheet option, and you will get a tab to open. I prefer the new worksheet, but you can do the output range below if you wish.
0.05 is 5%. I'm going to leave that as is. That's a pretty common alpha level for this type of hypothesis testing. Click OK. And here's the results of my ANOVA. Excel gives you the sum of squares, degrees of freedom, mean square, the F value, the P value, and the F critical value. What we're really interested in is the F value, the F critical value, and comparing the P value to the alpha level that we chose. We chose an alpha level of 0.05, and the P value is much smaller than that. That tells you that there's something significant going on, so you should reject the null hypothesis. The second reason why you should reject the null hypothesis is the F value from the ANOVA test is much higher than the F critical value listed. This is Stephanie from statisticshowto.com. Visit us for more articles and videos on...
So I'm going to go back to this slide. I think this is actually it. That kind of wraps up ANOVA. I'm going to be posting another video shortly, and that video is going to be like some Excel stuff. Actually I will open up Excel right now and do that. So just open up Excel. Again, this is an ANOVA, so let's go ahead and close that. Hit OK. So I'm just going to do group A, group B, and control. So control means I didn't get any intervention, and we'll do, I don't know, sample 10. Group A got an intervention. I'll say anxiety medication. Okay, anxiety medication A. And anxiety medication B. And this is no anxiety medication. So what we're going to do, options, we're going to go to the add-ins, analysis toolpack, go, and OK. And we're going to go with ANOVA single factor. And our input range is that. Group by columns. Labels are in the first row. We want a new worksheet, like I said, hit OK. Here is our ANOVA. This is actually statistically significant, well, you know. So go ahead and click up here, make it big. And you can see here, here's our F value. It's a big F value. Highlight that. Our P value is very little, which is what we like to see. That's kind of like the only two things that we're really looking for. So yeah, the p-value, this is we reject null because it is less than 0.5. Now we have that. That's how you do the ANOVA, and that's a video example plus me doing it and explaining it. And again, you can rewind it and watch it if you need to watch me do it again. So you have that now, and that will end the ANOVA recording today.